Here's how post-tensioning works. This model represents a typical modern type of bridge structure called a segmental post-tensioned concrete bridge. The bridge itself is composed of a series of segments. Each one of these is precast concrete, which means that it's made in a factory or a manufacturing facility somewhere off of the project site and then shipped to the site on a truck or on a barge. This, as you can see, is the segment of a hollow reinforced concrete box girder, and that extension on the top really just represents the future deck of the bridge, extending out over either side of the box. The bridge then, in this case, will be made of 5 individual segments, but somehow we have to figure out a way to hold the segments together. And that, of course, is the job of the post-tensioning. For the sake of my model, we're going to represent that high-strength steel cable, which is called a tendon, with this piece of rubber tubing. And the way the post-tensioning process works is that first we have to thread it through the individual segment of the bridge, anchor it at one end, so I'm anchoring it out here on the far side. We then pass that steel tendon through the next segment, and we can now bring those 2 segments together. We'll pass the segment through the next. We'll pass the tendon through the next segment, and again bring the additional segment into contact with our growing bridge. We then pass it through the next segment, bring it together, and finally the tendon is now passed entirely through the structure. At this point, we just have a slack tendon lying inside of a series of concrete segments. We need to add the force that's going to cause those segments to remain together, not only to be able to carry the self-weight of the beam, but also to be able to carry all those externally applied loads once the bridge is in service. To do that, we're going to take that huge, powerful hydraulic jack, we're going to mount it out here on the far side of our bridge, we're going to connect it to the steel tendon, and we're going to apply a tremendous tension force to that tendon, stretching it significantly, and then once the tendon is fully tensioned, we anchor it out here at the far end, cut off the excess tendon material, and we now have a bridge that's capable of carrying its own weight. We can now take it to our bridge site, set it up on top of the abutments, and we have a segmental, post-tensioned concrete bridge ready to be put into service. The tendons, which are stretched with enormous tension to pull the entire bridge together, have the effect of reducing or eliminating all of the tension in the lower portion of this bridge. And the positive effect of that post-tensioning process is both to reduce cracking in the concrete and to reduce the amount of deflection that the bridge undergoes when it's subjected to load. This is the essence of post-tensioned segmental bridge construction. Of course, real bridges can't be built on the ground and then lifted onto the supports in one unit as I did in my demonstration. Rather, individual segments have to be post-tensioned into place on the existing structure, one at a time.